Hello there, and welcome to Cosmic Titans. Wherever you are right now, take a quiet moment to notice your surroundings. Maybe you're lying in bed with a pillow comfortably behind your head, the room dim, with only a faint glow from a lamp or a street light slipping through the curtains. The air might be slightly cool, while the warmth under your blanket feels calm and reassuring, a small, simple comfort in the quiet of the night. Before we begin, just think for a moment about where you're listening from tonight. Maybe it's a busy city with distant traffic in the background, or a quieter place where the night feels deeper and still. Maybe you're in a familiar room or somewhere new. Wherever you are, this moment of quiet belongs to you. If this is your first time with Cosmic Titans, a soft and genuine hello. I'm glad you found your way here. If you've been here before, then you already know what this is. A slow, unhurried journey through something extraordinary. Something that invites you not to understand everything, but simply to feel the edge of it. To stand at the shore of something immense and let the water touch your feet. If you feel moved to leave a like or to subscribe so that more of these nights find their way to you, please do. It costs nothing and it helps others find this place. But there is absolutely no pressure, and I mean that in the truest possible way. The only thing that matters right now is that you are here and that you are resting or trying to rest, and that this voice can be one small part of whatever is helping tonight. And before we go any further, one small thing worth saying clearly and then setting gently aside. Everything you'll hear tonight is offered for relaxation, for wonder, for the particular pleasure of feeling small in the best possible way. It is not medical advice. It is not a substitute for care or for conversation with someone who knows you and can truly help you. If you have concerns about your health, about your sleep, about anything at all, please do speak with someone who can meet you where you are. Tonight, we are only here to float together through something extraordinary. Because tonight, we are going somewhere almost impossible to imagine. We are going to talk about the largest black hole ever discovered. Not just a large black hole, not even the one that held the record for years, the one whose name became shorthand for incomprehensible mass, the one that astronomers pointed to when they wanted to convey the outermost edge of what we had found. Not that one, though we'll spend time there too, because it deserves its moment. We are going somewhere beyond. Somewhere so vast, so ancient, so gravitationally overwhelming, but even the most carefully constructed metaphors will bend a little under the weight of it, the way light itself bends when it passes too close to something this massive. But we are going slowly, you know that. That's why you're here. Take a breath, a real one. Let it be a little slower than the last. And let's begin at the beginning. Not the beginning of the universe, not yet, but the beginning of understanding. Because before we can appreciate something impossibly large, we have to feel comfortable with the idea itself. We have to let the concept of a black hole settle into the body, not just sit at the surface of the mind like a fact waiting to be forgotten. We have to make it real in the way that real things feel real, not through memorization, but through something closer to recognition. You know the feeling of a drain in a bathtub? You've felt it countless times without thinking much about it. The way water moves toward that small dark opening with a kind of quiet inevitability. Nothing seems to be pulling it. The water just moves. Slowly at first, in long lazy swirls, and then faster as it gets closer. And finally it disappears into the dark with a small sound and is gone. You don't see a hand reaching up from below. You don't feel a suction from across the room. The drain just exists, and the water, given enough time and enough closeness, will find its way there. That is the most ordinary version of what we're talking about tonight, an attractor, a place that other things move toward, not because they choose to, but because the geometry of the space around that place makes moving toward it the path of least resistance. Now, imagine that drain had gravity, not the gentle pull of a bathtub drain, but a gravity so extreme that it didn't just pull water, it pulled everything. Sound, light, the very concept of distance. Imagine that once something moved close enough to that drain, it could not come back. Not because something was holding it, not because a lid came down or a lock engaged, but because the geometry of the space around it had changed so completely, so irrevocably, that the direction we call away, the direction that leads back to everything you know, the direction that leads home, simply ceased to exist past a certain point. That is a black hole. Not a thing, exactly. Not an object you could hold or touch or point to in the way you point to a stone or a star. More like a condition, a consequence. A place where gravity has become so extreme that space itself, the very fabric that everything moves through, the medium in which all of reality occurs, curves all the way around into something with no exit. A wound in space-time that heals over itself, that closes the door behind everything that enters it. They form in a few different ways, and the kind we care about tonight, the supermassive kind, the ones that sit at the centres of galaxies like sleeping giants of unimaginable proportion, did not form simply from one dying star. A single star collapsing, even a very large star at the end of its hydrogen-burning life, makes what we call a stellar mass black hole, something perhaps 10 or 20 times the mass of our Sun, enormous by human standards. A fact that, if you read it in a newspaper, would seem extraordinary, and yet in the context of what we're discussing tonight, it is a whisper, a grain of sand, a small note played quietly at the beginning of a symphony that will take the rest of the night to unfold. Supermassive black holes are a different category entirely. They are ancient, they grew. Over millions and billions of years in the churning, chaotic nurseries of early galaxies, they consumed gas and dust and entire clouds of molecular hydrogen. They swallowed stars that wandered too close. They merged with other black holes in collisions that sent ripples through the fabric of space-time itself. Each merger added to the mass. Each consumed cloud of gas added to the mass. Like a slowly growing debt or a slowly growing fortune, the principle compounds over time, and given enough time, the result can become something that bears no resemblance to where it started. The black hole at the centre of our own Milky Way galaxy, it has a name, Sagittarius A star, pronounced Sagittarius A star, and yes, the asterisk is genuinely part of the name, which feels like a small and charming piece of cosmic nomenclature, has a mass of about 4 million times that of our Sun. 4 million suns, compressed, folded, gathered into something so dense and so gravitationally powerful that stars orbit around it the way planets orbit our Sun, on timescales of years rather than centuries, moving at extraordinary speeds that can only be explained by the presence of something extraordinarily massive at the centre. And right now, as you lie there in the dark and breathe slowly and let the warmth of your bed hold you, Sagittarius A is there, not in some abstract theoretical sense, literally there, approximately 26,000 light years away from where your head is resting on its pillow. 26,000 light years is a distance so enormous that the light leaving Sagittarius A right now will not arrive at the place where Earth currently is for 26,000 years. By the time that light reaches here, our species will have had 26,000 more years of history, or won't be here at all, which is its own kind of thought, to let move through you and keep going. What? You are not watching this from a distance. You are inside it. You live in a galaxy, the Milky Way, a spiral galaxy containing somewhere between 200 and 400 billion stars, give or take, that orbits its own central black hole. Not falling into it, orbiting. At a safe and stable distance, the Sun and its planets and everything we have ever known circling the galaxy's centre in a vast, slow path that takes approximately 225 million years to complete once. In the entire history of recorded human civilization, every pyramid built, every empire risen and collapsed, every song composed, every child ever born and named and loved, the Sun has not completed a measurable fraction of one single orbit of the galaxy. We are that slow, the cosmos is that vast. And Sagittarius AB, at 4 million solar masses, is considered by astronomers to be a relatively modest supermassive black hole. Let that just sit in the room with you for a moment. Don't try to hold it, just let it be there. Now, let's talk about TON 618. There is a particular kind of wonder that comes from learning the name of something enormous, something almost too large to be real. TON 618. It sounds like a code, a designation, a bureaucratic label applied to something that deserves far more poetic treatment. And in a sense, that's exactly what it is, a catalogue number from a survey of distant objects, the way a naturalist in the field might tag and number a specimen before he fully understood what they're holding. The name is small. The thing it names is not. TON 618 sits at the centre of a distant quasar. Now, a quasar is something worth understanding, because quasars are among the most dramatic objects in the universe, and the word itself, short for quasi-stellar object, because when they were first observed through early telescopes, they looked almost like stars, but behaved very differently, has a kind of electric quality to it. A quasar is what you get when a supermassive black hole is actively consuming enormous amounts of matter. As gas and dust and stars spiral inward toward the black hole, they don't fall straight in. They form a disk, an accretion disk, flat and spinning, like an extremely dangerous cosmic whirlpool. And as the material in this disk spirals inward, friction and compression heat it to extraordinary temperatures, millions of degrees. At those temperatures, matter glows. And it doesn't just glow the way a hot coal glows. It blazes. It screams with light across the entire electromagnetic spectrum. A single quasar, powered by a single black hole actively feeding, can outshine an entire galaxy of hundreds of billions of stars, sometimes by a factor of 100, sometimes 1,000. Quasars are mostly a phenomenon of the early universe, when galaxies were younger and more chaotic, and there was more gas available to fall inward. Today, most supermassive black holes, including our own Sagittarius AW, are relatively quiet. The local supply of gas has thinned. The black hole is there, but it's not actively blazing in the way it once might have. It breathes very slowly, and what a breath it must be when it comes. But mostly it rests, as ancient enormous things eventually do. TON 618 is about 10 billion light years away from us. When we observe it, when the light entering our telescopes to create those images first left its source, the universe was less than 4 billion years old. Our sun did not yet exist. The Earth was not yet even a thought in the mathematics of an unformed solar system. The light from TON 618 has been travelling for 10 billion years, crossing the expanding universe, arriving at instruments that human beings built on a planet orbiting a star that formed more than 5 billion years after that light began its journey. The black hole at the centre of TON 618 has a mass of 66 billion times that of our Sun. Take that sentence slowly. 66 billion solar masses. If our Sun were a single grain of sand, a small, ordinary grain of sand, the kind that gets into your shoes at the beach and you don't notice until you're back in the car, then TON 618's black hole would be a beach. A long beach, stretching for miles. Every grain of sand on that beach, a sun. Every star our sky would ever show us, just one grain in a much larger handful. The event horizon of TON 618, the boundary, the point of no return, the last address in the universe before the laws of physics as we experience them cease to apply in any familiar way, has a radius of approximately 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, the distance light covers in about 8 minutes, travelling at 300,000 kilometers per second. That distance, multiplied by 1,300, gives you the radius of the event horizon of TON 618. The entire orbit of Pluto around our Sun, that long elliptical journey that takes 248 years to complete, that carries a small icy world billions of kilometers from the star that barely warns it, would fit inside the event horizon of TON 618 with room left over. Not a little room, substantial room. You could stack the orbital paths of several solar systems inside that boundary, and they would rattle around like seeds in a gourd. For years, this was the ceiling. This was the record. This was the name that appeared at the top of any list titled Most Extreme Objects Ever Observed. And it deserved its place there. It still does. TON 618 is extraordinary, and nothing we say tonight diminishes that. But there is something larger, and the way we discovered it is worth telling slowly, because the method itself is beautiful. Before we get there, a moment to check in with you. How are you doing? Is the room still quiet? Are your legs still and your breathing still slow? If your mind has been following along, good. If it wandered for a little while and is only now finding its way back to the sound of this voice, that's good too. You're allowed to drift. You're allowed to let this become something in the background, a texture, a sound that keeps the room company, while your thoughts do whatever they need to do. This is not a test. Nothing here requires retention. Right now, as you breathe, the atoms in your body are doing what they always do, cycling through the chemical processes that keep you warm and alive and here. The carbon in your cells, the oxygen your lungs are drawing in, the iron molecules in your blood carrying that oxygen from your lungs to your furthest fingertips, all of it moving in its quiet, reliable way. And those atoms were forged in stars. Not metaphorically, literally. The carbon was made in the nuclear furnaces of red giant stars billions of years ago. Stars that had names, probably, in the sense that they existed and had properties and a history. Stars that lived for millions or billions of years, fusing hydrogen into helium, into carbon and oxygen and heavier elements in their cores, and then one day, after all that time, those stars died. The larger ones went supernova, an explosion so catastrophic and so bright that it temporarily outshines the entire galaxy it lives in, scattering its contents into the surrounding interstellar medium. And those atoms drifted through the dark for a long time, for a very, very long time, until gravity gathered them again into a new cloud, and the cloud collapsed, and a new solar system ignited, and 4.5 billion years of geology and chemistry and biology later, those atoms found each other again, inside you. You are made of old starlight. You are a temporary arrangement of ancient cosmic material, lying in a warm bed, listening to someone talk about black holes. And the atoms that are you were present in some earlier form for everything. For supernovae, for the formation of solar systems, for the long drift through the dark between stars. You are not new to this universe. Only this particular arrangement of you is new. You are not watching this from outside. You are already inside it, now. Let's talk about how astronomers figure out how massive a black hole is, because without understanding that, the number we're about to encounter will feel like it exists only on a page somewhere, which would be a shame. You cannot weigh a black hole the way you weigh a suitcase before a flight. You cannot send something close enough to touch it, or to orbit it at a carefully measured distance and call home with data. The distances involved are too vast. The environments are too extreme. But there is a method, and it is elegant, and it relies on something you've probably noticed without ever thinking about it, as a scientific principle. When something moves in a circle around another thing, the speed of that movement tells you about the mass of the thing at the center. Think of a ball on a string, swing it in a circle. The faster it moves, the harder you have to pull on the string to keep it from flying outward. The string tension, the force required to maintain the circular path, tells you something about the mass being swung, and the speed, and the radius of the circle. The same logic works in reverse. If you watch an object moving in a circle, and you know its distance from the center and its orbital speed, you can calculate the mass of whatever it's orbiting. This is how we know the mass of the Sun, by watching the Earth's orbit. This is how we know the mass of Sagittarius A star, by watching stars very close to the galactic center complete their orbits over the years, as astronomers have patiently done for decades. Tracking the movements of individual stars as they swing around something invisible at the center of the galaxy, like tiny sparks orbiting a candle that cannot be seen. Their paths are curved, their speeds are known. The math produces a number, 4 million solar masses, sitting there, unseen, at the precise point where all those orbital paths converge. For more distant black holes, in other galaxies, direct stellar tracking isn't always possible. The distances make individual stars impossible to resolve, even with our best telescopes, so astronomers use other methods. They can look at the velocity dispersion of stars in the galaxy's core, essentially measuring how chaotically and quickly the stars in the central region are moving, which tells you about the gravitational well they're swimming in. The way the turbulence of water in a drain tells you something about the strength of the pull. They can use the light from glowing gas swirling near the black hole, measuring how the wavelengths of that light shift depending on whether the gas is moving toward or away from us. The Doppler effect applied at galactic scales. The same principle that makes an ambulance siren sound higher in pitch as it approaches and lower as it recedes, now applied to light rather than sound. They can model the overall structure of the galaxy, the shape of its brightness profile, and ask what mass at the center would produce this shape. Each method has its uncertainties, its error bars, its assumptions. When multiple methods converge on the same number, confidence grows. And the galaxy we're about to talk about has been studied with extraordinary care, precisely because what the measurements were suggesting seemed too remarkable to accept without rigorous verification. The galaxy is called Home 15A, a name that feels, if you say it aloud, almost architectural, almost quiet. Home 15A. It sits at the centre of a galaxy cluster called Abell 85, and a galaxy cluster is exactly what it sounds like. Not a single galaxy, not even a few galaxies near each other, but dozens or hundreds of galaxies spanning millions of light years, bound together by their collective gravity and moving through the universe as a loosely held community. Abell 85 is one such cluster, roughly 700 million light-years from here, containing hundreds of individual galaxies, each with hundreds of billions of stars. And at the centre of Abell 85 sits its brightest galaxy, Home 15A. The queen of its cluster, the galaxy that has grown fattest and most luminous, at the gravitational centre of all that collective mass. And at the centre of Home 15A, there is something enormous. A 2019 study examining the distribution of stellar velocities in the core of Home 15A, with careful attention to the modelling of the galaxy's inner structure, produced a measurement of the central black hole's mass. The number was approximately 40 billion solar masses, making it at that time, and by some accounting still, one of the largest directly measured black holes ever found. 40 billion times the mass of our Sun. And when further refinements were made, accounting for the complex dynamics of the stellar populations at the galaxy centre, some analysis put the estimate closer to 66 billion solar masses, matching, remarkably, the mass of TOND 618. But now, in an object we can study with far greater precision because it is so much closer. Others, incorporating the effects of gravitational lensing, have suggested the figure could be higher still. Let's stay with what is well established and still extraordinary. Home 15A. Star is one of the most massive black holes ever directly measured, in a galaxy close enough to study carefully, making it in many ways more concretely known to us than the more distant record holders. Its event horizon, that boundary past which nothing returns, spans a distance so enormous that light itself, moving at its invariant and uncuttable maximum speed, would take days to travel across its diameter. Not hours, days. Let that be a feeling in your body for a moment, not just a number in your mind. Think of all the things that happen in a day. The way light changes from morning to evening. The meals, the conversations, the moments you barely notice passing. A full rotation of the Earth on its axis. The movement of shadows across a floor. The slow accumulation of a day's worth of living. And in the time it takes the Earth to complete several such rotations, a beam of light moving at the maximum speed the universe allows would still be crossing the event horizon of Home 15A. It would not yet be through. Well, 5 minutes' time, it would still be inside the boundary, still making its way, still going. There is a particular pleasure, I think, in being small, not the painful smallness of feeling unseen or overlooked, not the kind of smallness that stings, the other kind. The kind that arrives when you stand at the edge of the ocean at night, when there is nothing visible beyond the breaking of the waves and the faint shimmer of whatever light reaches the water. Pyramids might be, pyramid, and you feel the cool damp of the sand against your feet, and you realize that this ocean has been here longer than your name, longer than your species, longer than the continent you're standing on, that it doesn't know you and doesn't need to, that it will be here after you, carrying on its ancient business. And somehow, that is not sad. Somehow, it is a relief. A loosening of something you didn't realize you were holding. That is the smallness I'm offering tonight, the kind that is a gift. Because if whole 15A star doesn't need you to tend to it, if it will be there curving space for billions of years without requiring your attention, then the thing you're quietly rehearsing in the back of your mind right now, the conversation you're replaying, the task waiting for tomorrow, the worry sitting quietly in the corner of your chest like an uninvited guest who doesn't quite know when to leave, that thing is also small, tenderly, generously small, real and yours and important in its own scale, but carried in a universe that is much larger than it and will carry it along without your assistance while you sleep. You are allowed to put it down for now. Let's talk about gravitational lensing, because it is one of the most beautiful predictions in all of physics, and because it plays a role in how we understand the mass of objects like Holm 15A*. In 1915, Albert Einstein published his general theory of relativity. It was, to put it plainly, a revolution in our understanding of gravity. Before Einstein, gravity was understood through the framework built by Isaac Newton: a force, a pull, something that acts between masses across distance. Newton's equations were extraordinarily successful and remain useful for most practical purposes to this day. But they didn't explain everything, and Newton himself acknowledged that he had no explanation for how gravity propagated across empty space. He described it, he quantified it, but he did not explain its mechanism. He called it action at a distance, and admitted he was not comfortable with it. Einstein's insight was to replace the concept of gravitational force with the concept of curvature. Mass, in Einstein's framework, does not pull other things toward it through an invisible force. Instead, mass curves the fabric of space-time, the four-dimensional medium in which all events occur. And other objects, moving through that curved space-time, follow the curvature. They follow the shape of the medium. An orbit is not an object being pulled in a circle. It is an object following the straightest possible path through curved space-time, a path that happens to be a curve from our limited three-dimensional perspective. This is not just beautiful philosophy. It makes specific, testable predictions. One of them, if mass curves space-time and light moves through space-time along the straightest available path, then light should be deflected as it passes near a massive object. A beam of light that passes close to the sun should not travel in a perfectly straight line. It should bend slightly, following the curve of the space-time the sun has created around itself. This prediction was tested in 1919 during a solar eclipse, when the positions of stars near the sun could be observed, stars that would normally be hidden behind the glare, but were visible because the moon was blocking direct sunlight. Their apparent positions were shifted from where they should have been. The light from those stars had bent around the sun exactly as Einstein had predicted. The result made international headlines. The theory was confirmed. Space bent around mass. Reality was elastic. Gravitational lensing is the large-scale version of that bending. When a massive object, a galaxy cluster, a black hole, sits between us and something further away, the light from the more distant object bends around the massive foreground object. Depending on the alignment and the masses involved, this can produce arcs of light. Rings of light, called Einstein rings when the alignment is near perfect, and multiple images of the same background object appearing in different parts of the sky. The background galaxy, like a reflection in a warped mirror, is stretched and curved and sometimes multiplied. But this distortion is not random. The degree of bending depends precisely on the mass doing the bending. And so the warped images of background galaxies are, for astronomers who know how to read them, a measurement, a weighing. The amount of distortion tells you the mass of the lens. For a mass like Holm 15A star, the lensing effect is substantial and measurable. The enormous gravitational influence of the black hole and its host galaxy leaves an imprint on the light of everything behind it, an imprint that carries information about the mass doing the imprinting. Think of it like this. Imagine you're in a dark room and you want to know where a large piece of curved glass is. You can't see it. There's no light falling on it directly, but you can see the objects behind it, and they look slightly wrong, slightly bent, slightly shifted from where they should be. The distortion of those background objects is itself a map of the glass's shape and position and curvature. That is what gravitational lensing does for astronomers. The distorted images of background galaxies bent by the gravity of Holm 15A star are a map of the mass doing the bending. They are evidence. They are the shape of the truth, written in curved light. The universe writes its own measurements in the light. You just have to know how to read the handwriting. Now let's talk about what it means for a galaxy to have a black hole this large at its center. Because the relationship between a black hole and its host galaxy is not the simple one-directional relationship of a drain and a bathtub. It is something more interesting, more mutual, more strange. Most large galaxies have supermassive black holes at their centers. This is not a coincidence. The formation of galaxies and the formation of supermassive black holes are intertwined, each affecting the other across billions of years, and a cosmic coevolution that astronomers are still working to fully understand. There is a well-established relationship between the mass of a galaxy's central black hole and the mass of the galaxy's central bulge, the dense, roughly spherical concentration of stars at the galaxy's core. The heavier the bulge, the heavier the black hole, in a consistent ratio that holds across galaxies of very different sizes and in very different parts of the universe. Why? How does a black hole at the center of a galaxy, occupying a region of space that is tiny compared to the galaxy as a whole, containing a mass that is typically less than 1% of the galaxy's total stellar mass, manage to be so precisely calibrated to the galaxy surrounding it? How do these two things, formed by different processes at different scales, end up so consistently correlated? The answer likely involves feedback. When a supermassive black hole is actively feeding, when it's in its quasar phase, blazing with the energy of infalling matter, it doesn't just sit quietly and grow, it releases energy. Enormous quantities of energy, jets of particles moving at close to the speed of light, can shoot outward from the poles of an active black hole, extending for hundreds of thousands of light years, reaching far beyond the edges of the galaxy itself. Radiation and winds of fast-moving particles blow outward through the galaxy, heating the gas, pushing it away, disrupting the conditions under which new stars can form. In this way, the black hole regulates its own feeding. As it consumes more material and releases more energy, it pushes away the very gas that would have fed it further, and the growth slows. As the growth slows and the energy output decreases, the gas can cool again, flow inward again, and the cycle continues. A self-regulating feedback loop operating over millions of years, tying the growth of the black hole to the growth of the galaxy around it, like two partners in a very slow dance. And a black hole the mass of Holm 15A implies a galaxy that has been through a great deal. The galaxy Holm 15A is itself an enormous, brilliant galaxy. It is what astronomers classify as a brightest cluster galaxy, the single most luminous galaxy in its entire cluster, sitting at the cluster's gravitational center, built up over billions of years through mergers with other large galaxies. When galaxies merge, their stars don't typically collide. The distances between individual stars are so vast that two galaxies can pass through each other with relatively few stellar collisions. But the gas in the galaxies does interact, and the gravitational dynamics are complex and turbulent, and the two central black holes, after the galaxies merge, will eventually find each other and spiral together and merge as well. Holm 15A shows signs of exactly this kind of history. The brightness profile of its inner regions, the way the intensity of its light changes as you move from the very center outward, has an unusual shape. Instead of a sharp, bright peak at the center, like most massive galaxies have, Holm 15A's core is remarkably flat, remarkably dim at the very center relative to what models would predict. This shape, called a core or a light deficit in galaxy morphology, is thought to be the signature of gravitational interactions over long timescales. When the two black holes and a merging pair of galaxies spiral toward each other, they interact with the stars around them, flinging individual stars outward through gravitational slingshot effects. Stars that venture close to the binary black hole can be ejected from the core at high speed, flying outward into the galaxy's outer regions, evacuating the center of the stars that once crowded there. Over the course of a merger, this ejection scoops out the central stellar population, carving a low-density core. The resulting flat, diffuse brightness profile is the scar of an ancient and enormous merger. Holm 15A wears its history on its face. Right now, as you breathe and rest, you are living in a galaxy that has its own such history, smaller in scale but following the same logic. Our galaxy, the Milky Way, will one day merge with the Andromeda Galaxy, not for about 4 billion years, long after any human concerns have resolved themselves one way or another. But the gravitational interaction between the Milky Way and Andromeda is already underway. The two galaxies are approaching each other, drawn together by their mutual gravity. The merger, when it comes, will be gradual. Billions of years of disruption and rearrangement. And the two central black holes, Sagittarius A star and the black hole at the center of Andromeda, will eventually spiral together, release a burst of gravitational waves powerful enough to ripple across the local universe, and merge into something larger than either of them alone. This will happen. It is written in the physics, in the gravity, in the slow closure of the distance between two enormous communities of stars. This is how it goes. This is how Holm 15A star got so large. A long history of collisions and mergers and consumption, galaxies and black holes combining over cosmic effects, each merger adding to the mass, each mass addition deepening the gravitational well, each deepened well drawing in more material, in a slow and patient accumulation that mirrors, at an incomprehensible scale, the way many of the most significant things in life are built, not in a single moment, but through the quiet persistence of time. You are not watching this from a distance. Right now, this is happening around you. The Milky Way and Andromeda are even now in the early stages of their long appointment. Sagittarius A is sitting quietly at the galaxy's center, 4 million solar masses of ancient dark, waiting in its unhurried way. The universe is doing what it has always done, following gravity, following time, rearranging matter at scales and over durations that make our concerns feel very small and very precious. Let your breath slow again. Let your muscles soften against whatever surface is holding you. Notice if your shoulders have dropped a little. Notice if your jaw has unclenched, even slightly. Your body wants to rest. It was built for rest. It relies on rest, and it will find its way there if you let it. I want to talk for a little while about gravitational waves, because they are beautiful and because they connect everything we've been discussing in a way that feels, if you let it, almost like music. When two massive objects orbit each other, two black holes, two neutron stars, two very dense and massive bodies in a close orbital embrace, they do not orbit forever without change. According to general relativity, an orbiting pair of masses loses energy through the emission of gravitational waves. Gravitational waves are not light. They are not electromagnetic radiation of any wavelength. They are something else entirely. They are ripples in the fabric of space-time itself, compressions and stretchings of the very medium through which everything moves, spreading outward from their source at the speed of light, diminishing with distance but never entirely disappearing. Imagine dropping a stone into a perfectly still pond. The ripples spread outward in concentric circles, growing larger in radius and smaller in amplitude as they travel. Now imagine that the stone is not a stone, but two black holes spiraling into each other. And the pond is not water, but space-time itself, the four-dimensional fabric of the universe. And the ripples are not on the surface, but in the structure of reality. The ripples pass through everything. They pass through galaxies, through dust clouds, through the empty spaces between stars, through planets, through you. Right now, gravitational waves from ancient cosmic events are passing through your body, very gently, without any physical sensation you could detect with any sense you have, compressing and stretching the space you occupy by an ounce so tiny, fractions of the width of a proton, or smaller, that no ordinary measurement could reveal them. But extraordinary measurements can. In 2015, the LIGO detector, the Laser Interferometer Gravitational Wave Observatory, an instrument of extraordinary sensitivity that uses laser light to measure changes in distance across kilometers-long arms, detected a gravitational wave signal for the first time in history. The signal lasted a fraction of a second. It represented the merger of two stellar mass black holes, roughly 1.3 billion light-years away. The signal had been travelling for 1.3 billion years to reach Earth. And when it arrived, it compressed and stretched the detector's arms by a distance equivalent to a fraction of the diameter of a proton, and the instrument patiently sensed it enough, painstakingly isolated from every other source of vibration, detected it. This was one of the most significant scientific achievements in human history, not just because of what was found, but because of what it opened. A new sense. For millennia, astronomy was done with eyes and light. Then, over the 20th century, we built instruments to detect other wavelengths of electromagnetic radiation. Each revealed a new layer of the universe. Gravitational wave astronomy opened something different entirely. Not a new wavelength of light, but a completely different kind of information. A new way to hear the cosmos, rather than see it. The universe has more to say than we realized, and now we have more ears. The mergers of supermassive black holes, like the eventual merger of Sagittarius A star with Andromeda's central black hole, will produce gravitational waves of extremely low frequency, too low for detectors like LIGO. But there are efforts underway to detect these very low frequency waves through a different method, pulsar timing arrays, which use the extraordinarily precise natural clocks that pulsars represent to detect tiny variations in their timing caused by passing gravitational waves. And results from these arrays, published in recent years, suggest that there is indeed a background of very low frequency gravitational waves filling the universe, a cosmic hum, produced by the superposition of gravitational waves from countless black hole mergers happening throughout the universe and throughout time. The mergers of galaxies, the spiraling together of supermassive black holes, has produced a background vibration that permeates all of space, The universe is humming quietly below any frequency you could ever hear. But you are swimming in it. Right now, the hum of ancient mergers passing through you in the dark. Isn't that something worth falling asleep to? Let's slow down a little more. Let the ideas settle like sediment in still water. You've travelled a long way tonight, in the most comfortable possible way, lying still while the universe unfolds around you. You've moved from the bathtub drain to the galaxy's centre, from Sagittarius A to Tom 618, from Tom 618 to Holm 15 AM. You've touched on the nature of black holes, the geometry of space-time, the way galaxies and their black holes grow together across billions of years, the way light bends around enormous masses to leave its measurement behind. The way gravitational waves carry the news of the universe's most violent events across billions of light years to reach instruments we built on a small planet in an outer arm of a middle-sized galaxy. You have covered, in the space of a quiet night in a warm bed, more distance than any human being has ever physically travelled. And you don't have to remember any of it. You are allowed to have already drifted off. You are allowed to drift off right now. This is not a lecture you'll be tested on. This is a story about where you live. The real where. The one that goes all the way out to the edge of what we know. And stories are allowed to end before they're finished. The last part can be dreamed. But for those who are still here, still following the thread in the quiet dark, let's continue a little longer. There is a concept in physics that I find deeply comforting, and it goes like this. The laws of nature are universal. Not universal in the casual sense of most people agree on this. Universal in the precise, literal sense. The laws of physics that govern the behaviour of matter and energy are the same everywhere in the observable universe. In every galaxy we have ever studied. At every scale, from the smallest subatomic particle to the largest structure ever observed. The equations that describe how gravity works, how light travels, how matter behaves, they don't change depending on where you are. They don't have local exceptions. They are consistent. This is extraordinary when you really sit with it. It means that the same equations we use to describe the orbit of the Moon also describe the orbit of a star around Sagittarius A, and the orbit of one black hole around another before their merger, and the behaviour of gravity around Home 15A. The same physics, applied at scales that range across more orders of magnitude than the mind can naturally hold. Consistent throughout, universal. And it means that you, lying here in your bed, are subject to the same physics as the most massive black hole ever discovered. You curve space-time by an amount so small it is immeasurable without extraordinary effort. But truly, your mass bends space around it, as all mass does, as the rules say it must. The same force of gravity that shaped the event horizon of Holm 15A star is the force that keeps you pressed gently into your mattress tonight. The same quantum mechanics that operates at the smallest scales operates in the chemistry of every breath you take, in the firing of every neuron that processes these words, in the warmth your body generates and keeps close under the blanket. You are not a spectator of physics. You are a participant. You are physics, temporarily organised into something that can think about physics. And that, whatever else might be said about the universe and your place in it, seems to me like something worth knowing before you go to sleep. Now let's talk one more time about scale. but differently than before. Not to overwhelm, to comfort, to ground you gently in the size of things so that the size of your own concerns can find its true proportion. There are approximately 10,000 stars visible to the naked eye on a very dark, very clear night. 10,000. That number is unimaginable. You could count to 10,000, slowly, over a few hours. You could picture 10,000 people filling the seats of an auditorium or a stadium section. 10,000 is a number your mind can hold. Our galaxy contains somewhere between 200 and 400 billion stars. That number is not imaginable in the same way. If you counted to 400 billion at one number per second, it would take about 12,700 years. You would have started counting before the Egyptians built the pyramids, and your descendants, generations removed from you in every direction, would still be counting. And yet, our galaxy is one of perhaps 2 trillion galaxies in the observable universe, each with hundreds of billions of stars. The total number of stars in the observable universe is estimated at around 200 sextillion, a 2 followed by 23 zeros. The number of grains of sand on all the beaches and deserts of Earth is estimated at around 7 or 8 quintillion, a 7 followed by 18 zeros. There are roughly 10,000 times more stars in the observable universe than grains of sand on Earth. Every grain of sand you have ever touched, every beach you have ever walked, every desert you have ever seen photographed, all the sand of all the Earth represents a tiny fraction of the total count of stars. And each of those stars was a nuclear furnace, burning for millions or billions of years, forging the elements that eventually found their way into planets and oceans and creatures and, at the end of a very long chain of improbable events, into you. You are made of 10,000 to 1 grain of sand to the beach stardust. The universe has been building toward you in its indirect and uncaring and extraordinary way for 13.8 billion years. And here you are, briefly, for the cosmological equivalent of less than a heartbeat, present, awake, or almost asleep, wondering. The largest black hole ever discovered is out there in the dark. All 15A, star, 66 billion solar masses, or possibly more, at the centre of a galaxy 700 million light years away. Having spent billions of years growing to its current mass through a patient and ongoing accumulation that will continue for billions of years to come. Its gravity curves space-time around it in a region so large that light cannot cross it in a day. It will outlast every star currently burning. It will be there when the universe has grown cold and dark and quiet, when the last stars have burned out and the last white dwarfs have slowly cooled to near absolute zero in the long dark between galaxies, still there, barely changed. Curving space, not going anywhere. And you are here, right now, breathing, warm, made of old starlight. Temporary, in the most beautiful sense, a brief arrangement of ancient stardust that managed, against all odds, to become something that could wonder at the scale of things. The universe doesn't need your help to be large. It doesn't need your attention to continue its long work. The black holes will spiral and merge and grow without you. The stars will live and die and scatter their atoms without you. The gravitational waves will hum through the fabric of space-time without you, and the galaxies will drift apart in the expansion of space, slowly moving beyond each other's light horizon over hundreds of billions of years without you. This is not a sad thing. This is the best possible news. It means you don't have to carry any of it. It means the universe is already handling the largest concerns. It means all you have to do tonight, the only thing genuinely required of you in this precise moment, is to let yourself rest. Let the surface beneath you hold you fully. Let your weight sink into it. Feel the give of it, the support of it, the simple physical fact of being held by something that doesn't ask anything of you in return. Gravity does this without effort. Matter does this without thinking. The universe arranged itself across billions of years of stellar and planetary evolution so that there would be a surface here for you to lie on, so that it would be the right temperature, so that the air would be the right composition, so that you could breathe and rest and wonder. Take a breath now, a slow one. Let your chest rise and your lungs fill, and then let it out. Slowly, completely, all the way to the bottom of the exhale, and let the pause before the next breath be as long as it wants to be. Your body knows how to do this. It has been doing it since before you had a name. Let your thoughts begin to thin out, not forcefully, just let them. Like a fire that's been burning all day and is now finally allowed to go down to coals. The heat is still there, the warmth is still there, but the urgency is gone. The flickering and the leaping are done. Just the slow orange glow of embers, steady and quiet, needing nothing. Somewhere in the dark tonight, in a direction you can't point to with your finger, but somewhere in the immensity, Home 15A star curves space around itself as it has done for billions of years and will continue to do for billions more. The cluster of galaxies it belongs to drifts slowly through the expanding universe, all of its hundreds of galaxies moving together, held by their mutual gravity, going wherever the universe takes them. No destination, no urgency. Just the ongoing fact of existence, carried forward by physics, untroubled by time, in the way that only very old and very massive things can be untroubled. And here you are. Small, warm, temporary, astonishing. There is a phrase I love from the history of astronomy. We are made of star stuff. Carl Sagan said it, in his quiet and certain way, meaning that the atoms of our bodies were forged in the nuclear furnaces of stars. But I want to extend it, just slightly, to say, you are not only made of star stuff, you are made of the same universe as all of this, the same physical laws, the same forces. The same physics that governs the inside of an event horizon also governs the chemistry of your cells. The same gravity that built Home 15A star presses you gently into your bed tonight. You are not separate from the cosmos. You are a small and temporary and completely genuine expression of it. The most massive thing we have ever found is out there in the dark, not threatening you, not requiring anything of you, simply existing in its enormous way while you exist in yours. And the fact that both of you, Home 15A star and this brief arrangement of matter, listening in the dark, exist in the same universe, governed by the same rules, made of the same fundamental stuff, is perhaps the most remarkable fact of you. Not that the universe is large, but that you are part of it. Let's come down now, slowly, from all of this height. Imagine you are floating, not falling, floating, the gentle suspension of a leaf on perfectly still water, held at the surface without effort, neither sinking nor lifting, just resting on the boundary between water and air. That is what the body can feel like if you let it, when it stops working against itself. When the muscles let go, one by one, of the tension they've been carrying, the tension in the jaw, the tension across the shoulders, the subtle and persistent clench that most of us carry without knowing until we stop and notice. You don't have to release it deliberately, just notice it. Notice it and give it permission to soften. That is usually enough. The stars outside, if you could see through your ceiling and your roof and the atmosphere above you, are there right now. The same stars that were there before cities, before agriculture, before language. The Milky Way stretching overhead, that pale band of light that is simply the view of our own galaxy from inside it, looking along the flat disk of hundreds of billions of stars. And at the centre of that band, 26,000 light years away, Sagittarius A sits in its quiet mass, patient and permanent, and 4 million solar masses of ancient dark. And beyond that, if you could keep going, past the edge of our galaxy, past the smaller galaxies that orbit it, past the local group of galaxies that we belong to, past the Virgo supercluster and the enormous filaments and voids that form the large-scale structure of the universe, past all of that, 700 million light-years away, Holm 15A curves space around itself in the deep dark. Massive beyond any single description, patient beyond any human concept of time. You don't need to go there. You're already part of the same universe. You're already connected to all of it by the simple fact that you exist, that you are made of the same physics, that the atoms in your body were born in the hearts of stars and will one day, billions of years from now, return to the stars and the dark. You are not separate from the cosmos. You are a small, temporary, astonishing expression of it. Let your thoughts soften now. Let the edges of everything blur a little. You don't need to hold any of this. It will hold itself. The largest black hole ever found is out there in the dark. TON 618, which we used to call the ceiling, has become just another remarkable step on a staircase that goes higher than we knew. And somewhere above even Holm 15A, in galaxies we haven't yet fully resolved, there may be something larger still. The universe is not finished surprising us. It never has been. Every time we think we've found the edge of the map turns out to have more pages. But that is a story for another night. Tonight, the exploring is done. Tonight you have travelled far enough. Let your body be heavy now. Let the weight of the day settle fully into the surface beneath you. You've been carrying it long enough. The bed is here. The quiet is here. The universe is here, enormous and indifferent in the most comforting sense, going on without your assistance, handling its own vast business while you rest. Your breath is slowing. You may have already noticed, some time ago, that shift, that subtle, reliable shift when breathing stops being something you think about and becomes just something the body does on its own. That quiet rhythm, in and out, like tides coming in and going out, like the slow pulse of something very old and very calm, that doesn't need to think about what it's doing to do it perfectly. The universe continues. the largest black hole we've ever found, curves space around itself in the dark, not needing anything from anyone, not going anywhere, its event horizon spanning a region that light takes days to cross. Its mass accumulated over billions of years of patient gravitational work, its future extending for timescales that make the current age of the universe look like a single note in an endless song. And you are here. Here in this room, in this body, in this breath. Here and warm and held and small in the best possible way. Drift now, if you're ready. The stardust in you knows how to rest. It has been resting, in one form or another, for billions of years. This is just one more night of it, one more small chapter in the longest story. The universe is patient. It will still be here when you wake, and so will the wonder. Good night, and may the stars above and the stardust within keep you company as you drift into rest. But wait, you're still here, and there is more. There is always more with the universe. Let's talk for a while about time. Not the kind of time that fills your phone calendar. Not the kind measured in appointments and deadlines and the number of days until something you're either dreading or anticipating. The other kind. The deep kind. The kind that makes your personal timeline look like a single pixel in a photograph the size of a continent. The universe is approximately 13.8 billion years old, not 13.8 thousand, not 13.8 million, 13.8 billion years. If you compressed that entire history into a single calendar year, a common exercise in perspective, each month would represent more than 1 billion years. The Big Bang would be on January 1st. The Milky Way galaxy would form around mid-March. Our sun would ignite on September 2nd. The Earth would solidify shortly after. The first simple life on Earth would appear around September 21st. Complex multicellular life would not arrive until mid-November. The dinosaurs would appear on December 25th, and all of recorded human history, every civilization, every invention, every person you've ever heard of, would occur in the last 14 seconds of December 31st. 14 seconds. In the cosmic calendar, you are living in the last heartbeat of the last second of the last minute of the last hour of the year. And in those 14 seconds, a species evolved that could figure out how to weigh a black hole 66 billion times the mass of the Sun, 700 million light years away. A species that built instruments sensitive enough to detect gravitational waves from mergers that happened 1 billion years ago. A species that looked up at the night sky and was not content to merely name the lights, but wanted to know what they were, and then found out. That is what humans are. That is what you are. A temporary arrangement of stardust in the last sliver of the cosmic calendar who managed, in that brief window, to reach out and touch the edges of everything. There is something in that I find almost unbearably moving. And it is all the more reason to rest, because the work of knowing the universe is ongoing, and it needs rested minds to do it. Every scientist who looked at the data from Holm 15A and ran the calculations and revised the models and published the papers, every one of them slept. Every one of them had nights like this one, lying in the dark, probably not thinking about black holes, probably thinking about something much smaller and much more immediate. And then they woke up and went back to the extraordinary work of measuring reality. You don't have to be one of those scientists. You just have to be here, present, alive, part of the species that is doing this remarkable thing. Let your awareness move slowly around your body without effort or agenda. Just checking in. The weight of your head on the pillow, is it comfortable? The position of your hands, wherever they are, they can stay there or shift, whichever feels easier. Your feet, wherever they've settled. These are the things that are real in the most immediate sense tonight, not the black holes, as real as they are, not the light years and solar masses and event horizons. Those are real in the largest sense. But this, the pressure of the pillow, the warmth of the blanket, the rhythm of your breathing, this is real in the most personal, most immediate, most completely yours sense. Both kinds of real are valid. Both deserve attention. But right now, the smaller real gets to win. I want to tell you something about how black holes were actually predicted before they were discovered. Because there is something beautiful in the idea of knowing something exists before you've seen it. Knowing it because the math says it must be there. Einstein published his general theory of relativity in 1915. Within months, a German physicist named Karl Schwarzschild, who was at the time serving in the German army on the Eastern Front of the First World War, doing artillery calculations during the days and physics during whatever quiet hours remained, solved Einstein's field equations for the case of a perfectly spherical mass. He found that the equations produced a surprising result. There was a radius, now called the Schwarzschild radius, at which the mathematics broke down. Below that radius, the geometry of space-time became something that had no normal physical interpretation. A sphere of that radius around a sufficiently compressed mass would create a region from which nothing could escape. Schwarzschild sent his solution to Einstein from the trenches. Einstein was reportedly amazed that anyone had managed to find an exact solution to his new equations at all. He had not expected exact solutions to be easily available. He presented the results to the Prussian Academy of Sciences early in 1916. Schwarzschild died a few months later, not from a bullet, but from an illness contracted at the front. He never knew what his mathematics had predicted. He didn't live to see the concept of a black hole become a recognized feature of the universe. He didn't live to see his radius, the Schwarzschild radius, become a fundamental quantity in astrophysics, used to describe the size of event horizons, from stellar mass black holes to objects like Home 15A*. There's something about that, about knowledge outliving the person who found it, about a calculation made in the trenches of a terrible war, becoming a cornerstone of our understanding of the most extreme objects in the universe. That feels like it belongs in the long story we've been telling tonight. Every piece of understanding builds on every previous piece. The physics of a sphere, worked out by a dying soldier in 1915, is part of the chain that leads to the measurement of a 66 billion solar mass black hole more than a century later. Knowledge is a long game, and it is one of the things that persists when everything else is temporary. Hello there, and welcome to Just About Earth, where quiet curiosity meets the deep end of science, and wonder is allowed to take its time. Tonight, we're not going to talk about how the universe began or where it's heading. Instead, we're going to look at our own feet at something a little unsettling, something simple but not easy. What if we're not the first? Not the first thinkers, builders, explorers? What if, long before pyramids and satellites and bedtime science channels, Another civilization lived here on Earth, rose to something complex, and then vanished. I don't mean mythical lost continents or alien tourists. I mean an actual civilization. The universe is full of things that are doing exactly what they were always going to do, following the laws that have governed matter and energy since the first moments after the Big Bang. The black hole at the center of Home 15A is doing what supermassive black holes do, existing, curving space, occasionally consuming infalling matter, slowly and imperceptibly losing energy through the quantum trickle of Hawking radiation, waiting out the deep future in its patient, enormous way. It is not doing anything other than what it is. It is fully and completely what it is, with no ambiguity about that, no doubt, no second guessing. There is a strange kind of peace in that, if you let yourself feel it. You, in your smaller and more complicated way, are also doing what you do. Right now, that means lying in the dark and being a human, which includes the being kept awake part and the breathing slowly part, and the part where thoughts still drift through even when you're trying to let them settle. This is also just what you are. You don't have to be different from this tonight. You are allowed to be exactly this, a temporary, complicated, wandering creature at the edge of sleep, trying to rest, successfully resting a little more with every passing minute, even if it doesn't feel that way. The atoms in your body are at this moment participating in millions of chemical reactions simultaneously. Your nervous system is doing its ongoing maintenance. Your muscles are relaxing, slowly and incrementally, without instruction from you. Your brain is doing the complex and still not fully understood work of transitioning towards sleep, consolidating memories, cleaning metabolic waste through the lymphatic system, doing the housekeeping that can only be done when the daytime activity quiets down. You don't have to manage any of this. It is happening. The body is extraordinarily competent at the business of being a body. Let it do its work. Your only job right now is to do nothing. You're very good at that. You just have to remember, let's talk, gently, about what lies beyond the edge of the observable universe. Not because it will help you sleep, it might not, but because it is one of those ideas that tends to produce, in the right frame of mind, a particular kind of cosmic vertigo that is very close to wonder, and wonder, I found, is one of the quieter routes into rest. The observable universe is a sphere centered on where you are, with a radius of approximately 46 billion light years. The reason it has a finite radius is not because the universe ends there, but because beyond that distance, the expansion of the universe is so fast that light from those regions has never had time to reach us. Those regions exist, they are real, but they are, for us, permanently unreachable and permanently invisible. We cannot send a signal to them and expect a response. We cannot observe them. They are beyond our light horizon, separated from us not by solid walls, but by the most intimate kind of distance, the distance that cannot be crossed in any finite amount of time. The observable universe contains those 2 trillion galaxies we mentioned earlier, but the full universe, the whole thing, beyond our horizon, may be vastly larger. Some theories suggest it is infinite in extent. Infinite, meaning not merely large, but without end in any direction, with no edge, no wall, no final galaxy beyond which there is nothing. Just more universe, going on without limit, filled presumably with the same kinds of structures we see here, galaxies and clusters and superclusters and voids, black holes at the centers of galaxies, stars burning in their long cycles of birth and death, planets orbiting those stars, and here and there, perhaps, other arrangements of matter that have managed to become conscious and look up and wonder. The implications of this are something that philosophers and physicists have thought about for a long time. If the universe is infinite, then every possible arrangement of matter that can exist must, somewhere, exist, including arrangements very similar to the one you inhabit right now. Not identical. The randomness of quantum mechanics ensures that every history is unique, but similar. Other versions of this night, slightly different, playing out in the unimaginably vast region beyond our horizon. You don't have to believe this. It is not proven. It may not be true. But it is a real possibility that follows from the mathematics of inflation, from the models of the early universe that best explain what we observe. And there is something in it, the idea that somewhere, beyond any reach, this night is happening in other forms, other versions of something like you, encountering something like this, that I find oddly comforting. As if the universe takes what exists and doesn't just use it once. But we are here, in this version, on this night, and this one is the only one you have access to. So let it be enough. Let this room be enough. Let this breath be enough. There is a concept that physicists use called the cosmic perspective, the idea that understanding the scale of the universe does not diminish you, but rather reveals your true context. You are not a small thing in a large universe. You are a part of the universe that became aware of itself. You are the universe thinking, for a brief and unlikely moment, about its own midget. Every measurement ever made, every equation ever solved, every night of wondering like this one, all of it is the universe, doing what seems, improbably, to be one of the things it does, generating the conditions for complexity, for life. For consciousness, for curiosity. The question of why this happens, why in a universe of hydrogen and helium and the occasional heavier element, matter sometimes organizes itself into something that wonders, is not one that physics has answered. Maybe it never will. Maybe it is not the kind of question that has an answer, in the way that how massive is Home 15A star has an answer. Maybe it is the kind of question that you just have to hold, the way you hold a warm cup of tea, not to consume it, just to feel it in your hands, to be grateful for the warmth. You are the universe wondering about itself tonight. And in a few minutes, or perhaps already, you will be the universe resting, which is also something the universe does, in its own way. The stars burn for billions of years and then they rest. The black holes grow through active feeding phases and then they rest in quiescence. Everything in the cosmos has its periods of intensity and its long periods of quiet. This is your quiet period, your long, slow night between one day and the next. The active part will return in the morning, the wondering will return. But right now, the quiet is here, and it is yours, and you have earned it. Home 15, A star, is out there, 66 billion solar masses, event horizon spanning days of light travel time, ancient and enormous and patient. It doesn't know you exist. It curves space around itself without knowledge of anything outside it. But you know it exists. That asymmetry, you knowing it while it doesn't know you, is what it means to be conscious in the universe. You contain the universe in a way the universe does not contain you, not in size, in awareness. That is an extraordinary thing to be. And now, awareness is ready to rest. Let the thoughts continue to slow. The ones that are still moving, still circling, let them move at whatever pace they need to, but don't chase them. Don't try to catch them or resolve them or push them away. Just let them orbit, slowly, at a safe distance, growing more distant with each revolution, taking longer and longer to come back around, until they're too far away to notice. The room is quiet, the air is cool against your face, the warmth around you is steady and reliable. The weight of your body against the bed is the most permanent thing you've felt all day. That steady, reliable heaviness that means you are here, and here is real, and real is enough. Let your eyes, if they haven't already, stop trying to see through the dark. There is nothing to see tonight that isn't already inside you. All the black holes and the light years and the ancient starlight are already part of what you're made of. You don't need to look for them. You are them in a small and temporary and completely genuine way. Good night. The universe continues. The largest black hole ever discovered sits in its dark at the center of its galaxy, 700 million light years away, not hurrying, not waiting for anything, simply being what it is with perfect consistency. And you are here, small and warm and temporary and real, part of the same story, part of the same physics, part of the same long accumulation of matter and time that made this night possible, that made your existence possible, that made the wondering and the resting and the slow drift towards sleep possible. The stars above are real. The stardust in you is real. The quiet in this room is real. And right now, that is everything. Let the last thought become the last wave on a quiet shore, coming in slowly, barely breaking, pulling back in the soft drag of sand and water, and then the next one, softer still, and the next, barely there, and then just the sound of the water, and the dark, and the rest. Good night, and may the stars above and the stardust within keep you company as you drift into rest. But there is still more to say, if you'll let me sit with you a while longer in the dark. I want to tell you about the moment in 2019 when human beings, for the first time in history, actually saw a black hole. Not inferred one from stellar orbits or gravitational lensing or the behavior of surrounding gas. Saw one as directly as instruments allowed. The Event Horizon Telescope, which is not a single telescope, but a global network of radio observatories working together, distributed across the Earth from Hawaii to the South Pole. Synchronized by atomic clocks, accurate to within a fraction of a nanosecond, collectively forming an effective telescope the size of our entire planet, turned its attention to two targets. One was Sagittarius AB, the black hole at the center of our own galaxy. The other was the supermassive black hole at the center of a galaxy called Messier 87, roughly 55 million light-years away, with a mass of 6.5 billion solar masses. Smaller than Holm 15A, but close enough and surrounded by enough active material to image in detail. The image, when it was released, was blurry by the standards of what we might want. It looked like a bright, glowing ring surrounding a dark central region, the photon ring, the glow of superheated gas orbiting just outside the event horizon, and inside it, the shadow of the black hole itself, the place where light simply did not come back. It was orange and fuzzy and asymmetric, brighter on one side because the gas on that side was moving toward us and its light was boosted by the Doppler effect. It was also one of the most significant images ever produced. For the first time, we were looking at an event horizon, a real one, the actual boundary past which nothing returns. The visual proof of something that had been predicted mathematically more than 100 years before. Standing between us and that image were the collected efforts of more than 200 scientists, decades of radio astronomy, the coordinated operation of telescopes on multiple continents, the solution of enormous computational problems, and the careful, patient, brilliant work of people who had devoted their careers to seeing something that most people assumed could never be seen. When the lead researcher, Katie Booman, who developed the imaging algorithm that made the picture possible, saw the first reconstructed image appear on her screen, she was in her late 20s, a PhD student turned postdoctoral researcher. The photograph of her reaction became almost as famous as the image itself. Her hands over her mouth, the brightness of her face. The specific kind of joy that comes when something you've worked toward for a long time is suddenly, undeniably real. That is also the universe doing something extraordinary. Not just the black hole, the reaction, the human being experiencing the confirmation of something beautiful and true. Both things are real. Both things are worth knowing. The image of Sagittarius A followed a few years later, harder to obtain because our own galaxy's centre is cluttered with gas and dust, and because Sagittarius A varies its brightness quickly, requiring more complex processing. But it arrived. Another orange ring, another dark centre. The heart of the Milky Way, 26,000 light years from where you are sleeping, made visible for the first time. We have now seen black holes directly as we can see anything that does not emit light of its own. And Home 15A, star whose mass dwarfs both of these, is too far away for the current generation of instruments to image in the same way. But it is known, measured, real. A fact in our collective understanding of the universe, placed there by the patient work of people who looked at the light from a distant galaxy and, through careful analysis, extracted from that light the mass of the darkness at its centre. Darkness that tells you things if you know how to ask. You know, I think the thing I find most comforting about all of this, the thing that has nothing to do with the size of black holes or the age of the universe or any particular number, is the simple fact that people care. That there are human beings who wake up every morning thinking about Home 15A star, who spend their working lives trying to measure masses in distances that have no bearing on their own day-to-day survival, no immediate practical application, no guaranteed reward. They do it because the universe is interesting, because the question of how large things can get is a genuinely fascinating question, because the edge of the map is a real place that can be found if you look long enough and carefully enough and with good enough instruments. There is something deeply hopeful in that. In the middle of every difficulty the human world offers, there are people building telescopes and running algorithms and revising models and writing papers about the largest black holes ever discovered. The work of understanding continues, as it is always continued, regardless of everything else that is happening. It is one of the most persistent things about the species, the curiosity, the reaching toward what we do not yet know. You are part of that species, even lying here in the dark, doing nothing more active than breathing and listening. You are part of the tradition of wondering. You chose to spend some of this night thinking about black holes. You chose to let the scale of things move through you. That is not a small thing. That is, in its way, a continuation of the same impulse that drove Karl Schwarzschild to solve equations in the trenches, that drove Katie Booman to develop algorithms that could reconstruct the shadow of a black hole, that drives every astronomer who has ever looked up and wanted to know more. You belong to the wandering species, and the wandering species needs to sleep. So let's let the wandering rest for tonight. Let it fold gently into something quieter, something that doesn't ask to be resolved. The question of what lies beyond our observable universe, unanswered. The question of what happens inside a black hole singularity, unanswered. The question of why the universe exists at all, rather than nothing. Deeply, persistently, gloriously unanswered. And that's okay, more than okay. The questions that can't yet be answered are the ones that will keep the curiosity alive. They are the unlit rooms at the end of a hallway, the pages at the back of a book you haven't turned to yet. They are waiting. They have been waiting for billions of years. They will wait a little longer. Tonight, the wandering goes to sleep. Gently. Like all good things that need rest before they can continue. Notice how your breath has been doing its work this whole time, without your asking. In and out. The oxygen entering your blood through the thin tissues of your lungs. The carbon dioxide leaving. The ancient chemistry of respiration, unchanged in its essentials since the earliest oxygen-breathing creatures first evolved to use the atmosphere that photosynthetic organisms had spent 2 billion years building. Every breath you take is connected to that history. Every breath is part of a chain so long it predates the formation of the solar system. Whatever newness you carry, the particular arrangement that is you, the specific version of this particular life, that is recent. But the matter of you is old, incomprehensibly old, and it knows how to rest. It has been resting between periods of activity for longer than anything you could imagine. Let it rest now. One final thought before the last wave reaches the shore. The light leaving Holm 15A's galaxy right now, in this moment, as you breathe slowly in the dark, that light will travel for 700 million years before it reaches the region of space where Earth is. If we are still here in 700 million years with instruments to collect that light, what will we make of it? What will the species that collects it know about Holm 15A star that we don't know tonight? How will our 70-line summary of an enormous black hole look to the beings who have spent 700 million more years studying it? We can't know. But we can know this: the light is coming. It left 700 million years ago, before the first land plants, before the first forests, before the first insects. And it is en route, moving at the maximum speed the universe permits, carrying information about one of the largest things that has ever been found. And one day, whether or not anything is there to receive it, it will arrive at the place where Earth is now. Light doesn't know if anyone is listening. It just travels, because that is what light does. And you, right now, in this moment between the end of today and the beginning of tomorrow, you are also traveling, not through space, through time. At 1 second per second, which is the only rate available to you, carried forward by physics, not requiring effort. Going where the night takes you. Go. Let it carry you. The universe, you see, is watching over nothing and everything all at once, without preference, without judgment, in the way that physics watches over things, not with attention exactly, but with absolute consistency. The laws, they will hold. Gravity, it will hold. The light, it will travel. The black holes, they will curve space. And you, my friend, you will sleep. You will sleep, and the universe, it will continue, as it always has, carrying on without needing you to be. Good night, and may the stars above and the stardust within keep you company as you drift into rest. And if you're still here, still awake, still listening, still following the thread through the dark, then let me give you one more gift before the night is done. Let me tell you about the void. Between galaxies, between the great clusters and superclusters and filaments that form the large-scale structure of the universe, there are voids, enormous regions of nearly empty space, hundreds of millions of light years across, containing very few galaxies compared to the dense filaments that surround them. One of the largest known is called the Boötes Void, roughly 250 million light years in diameter, containing far fewer galaxies than an average region of space its size would hold. When astronomers first discovered it in 1981, one quipped that if the Milky Way were inside the Boötes Void, we wouldn't have known there were other galaxies until 1960s. It is that empty. But empty, in the context of the universe, is still not nothing. Even in the deepest voids, there is something. Dark matter, that mysterious, invisible component of the universe that does not emit or absorb light, but does have gravitational mass, permeates everything, including the voids. The quantum vacuum, the baseline state of even perfectly empty space, sieves with virtual particles, flickering in and out of existence too quickly to observe directly. There is no true nothing in the universe. Everywhere you look, something is happening, even in the emptiest places we can find. Which means that you, in your bed, in your room, in your city or your countryside, surrounded by the most ordinary and immediate things, walls, furniture, air, fabric, a pillow against your cheek, are in one of the densest, most complex, most eventful regions in the universe. A planet, a biosphere, a civilization, a mind. All of this in a galaxy, which is already a high-density region compared to the voids between clusters. You are not in the empty space between filaments. You are at a node of extraordinary complexity, nested inside structure upon structure, all of it humming with activity. And you are resting, which is, in the context of all that activity, a remarkable act. Conscious life pausing itself. The complexity, reducing its own signal, voluntarily, so that it can continue. Rest is not the absence of the story. Rest is part of the story. It is how this story sustains itself. You are sustaining yourself. That is a good thing. The last stars of the night have turned, as the earth has turned beneath them, and wherever you are, the sky outside is doing what it does, either dark and starlit, or clouded, or bleeding the first light of approaching morning, depending on where and when you are. The sky doesn't need you to watch it. It does what it does, beautifully, without an audience. The stars rise and set, the planets move along their ancient paths. The light of distant galaxies, including the light from Home 15A and its enormous dark heart, continues its 700 million year journey, not knowing it is on the way to anywhere at all. And you are almost there, almost at the place sleep takes you, the quiet interior space where the brain finally lets go of its grip on the waking world and begins its other work, the maintenance, the consolidation, the dreaming that may or may not mean anything, but that the brain seems to need, the way a garden needs rain. Let the rain come now. Let the night do what nights are for. The largest black hole ever discovered, it'll still be there tomorrow, and the day after, and for timescales so vast, so incredibly vast, that the word tomorrow loses all meaning long before the thing changes in any noticeable way. It is not going anywhere. It will wait for you. The universe will still be extraordinary in the morning. The wondering, that can resume then. But for now, your body, your breath, the bed, the cool air on your face, the warmth around you, and the darkness, and the quiet. These are enough. You are enough. Good night, and may the stars above and the stardust within keep you company as you drift into rest. And if dawn is still hours away, and sleep is still at the edge of the room but hasn't quite arrived, that is perfectly fine too. You are resting. Even lying still with a wakeful mind is rest for the body. Even partial sleep is sleep. Even this quiet, this dark, and this one long breath out counts. The body, you see, is less demanding than we think. It doesn't need perfect conditions. It just needs us to stop working against it. Stop working against it. Let the darkness be full and complete. Let the silence have its full weight. Let the distance between you and everything you're carrying grow a little greater with each breath, until the carrying is barely something you notice at all. 66 billion solar masses, 700 million light years away, an event horizon that light takes days to cross, a galaxy that wears its merger history on its face, a black hole that will outlast the stars, a universe that preceded you by nearly 14 billion years and will continue after you for timescales no word contains, and you, here, now, breathing. Good night. Hello there, and welcome to Just About Earth, where quiet curiosity meets the deep end of science, and wonder is allowed to take its time. Tonight, we're not going to talk about how the universe began, or where it's heading. Instead, we're going to look at our own feet, at something a little unsettling, something simple, but not easy. What if we're not the first thinkers, builders, explorers? What if, long before pyramids and satellites and bedtime science channels, another civilization lived here on Earth, rose to something complex, and then vanished? I don't mean mythical lost continents or alien tourists. I mean an actual civilization,